Welcome back for another example about how to find the residue of a function. So let's suppose that we have these other functions. So what's the residue of the function f of z equal z cosine of z over z minus pi cube with at, as some other books put it, z0 equal to pi. Right. How do we deal with this? Well, the numerator, z cosine of z, doesn't have any pole at z equal pi, which basically means that the new denominator is the only one that contributes to the fact that there is a pole at z equal pi. Now, since the denominator is z minus pi cubed, we can say that z0 equal pi, it's a third order pole. So z0 equal pi is a third order pole, or order, as John Bercow will say. Yeah, we salute you, Mr. Speaker. Anyway, jokes aside, now what do we do with this? In this case, we can use a slightly different strategy. And we can call this strategy, we can basically say that we're going to use 3 points on this strategy. Point A is, let's multiply f of z by z minus pi cube. So what do we do? Well, we take z minus pi cubed and we multiply, so times f of z, which is this thing here, which is equal to, well, it would be like getting rid of this. So it's just the numerator, so z cosine of z. Now point 2, so point B. Differentiate n minus 1 times. So what does it mean? Well, it means that z minus pi cubed is a third order pole, because we said that the numerator doesn't contribute to the fact that there is a pole in z equal to pi, and it's only the denominator that contributes to the fact that there is a pole at z equal pi. And since the denominator is z minus pi cubed, we said that this is a third order pole. So to differentiate n minus 1 times basically means that we gotta differentiate n, so 3, minus 1, 2 times. In other words, we're going to take the second derivative of z. Of the whole thing, so of this one times the function. So z minus pi cubed f of z. Now, without doing any complicated math, it's pretty easy to see that the derivative of this thing is actually negative 2 sine of z minus z cosine of z. Third, so step 3, step C, you can substitute z equal to pi and divide by the factorial of n minus 1. So n minus 1 factorial. Which basically means that we're gonna say that the residue in pi is equal to, well, we're gonna be taking the whole result here from the step B, in which we're gonna substitute z with pi. So -2 sine of pi minus z cosine of pi, pi cosine of pi over, I'm gonna divide by the factorial of n minus 1, so n minus 1 factorial. So again, 3 third order pole minus 1, so 3 minus 1 factorial. So our pi is equal to -2 times, well, sine of pi, which is 0, minus pi cosine of pi, which is -1, so times -1, over 3 minus 1 factorial, which is 2 factorial. Again, our pi is equal to -2 times 0 is, well, 0, plus, because we have minus and minus, so plus pi times 1 is pi, over 2 factorial is 2 times 1, which gives us finally the residue in pi, which is, well, 0 plus pi is pi, and 2 times 1 is 2. So pi over 2. And this is the answer to our question. So what's the residue of this function at z0 equal pi? Well, it's pi over 2.